Okay, another question can come like this, where they bring for you something like this. Okay, they bring for you something like this. Yeah, they can even bring for you something like this. Okay, and then they ask you, okay, oh, it's coming like this, it's coming from here, sorry. Yeah, like that, then like this also. And then here it can be 0, it can be 10, it can be 20, here it can be 30. Okay, and then there it can be, let's say, 10. So this is velocity in meters per second. And then they ask you, 1, calculate the acceleration. Okay, in the first 5 seconds, in the first 10 seconds, 10, not 5, the first 10 seconds, the first 10 seconds, 10 seconds. So calculating the acceleration in the first 10 seconds. What do we have? Acceleration in the first 10 seconds. So acceleration is equal to final velocity minus initial over time. By this time, you know now how to do this. What's the final velocity? I'm starting from 0, initial. Final velocity is 10, and I took 10 seconds. So initial velocity 0, final velocity 10. Okay, in final velocity is 10. I started from initial velocity 0, and I took 10 seconds. And the 10 minus 0 is 10. 10 divided by 10 is 1. So 1 meter per second squared. Okay, 1 meter per second squared, that's acceleration. Okay, but B, calculate the distance in the whole journey. So it means all the areas of those triangles, of those shapes. Remember what I said, when calculating the distance, you use areas. So it means when I'm calculating distance, I use areas. So it will be the area of this triangle plus the area of that triangle plus the area of this triangle. So the area, this is area 1, this will be my area 2, that will be my area 3. I think I explained when calculating distance, you use areas. So calculate the distance of the whole journey. So distance, for distance, I use areas. That's what we said. Distance, you use areas. Distance, you use areas. Okay, so area of the first triangle, and then there's a rectangle, and then at the end there's like a triangle like this. So here it's 10, there it's 10 height from the diagram. Okay, and then from here to here, what's the distance? It's 20 minus this 10 to find this distance, so it's 10 also. So it is 10. So the distance here it's 10. Why? Because it was got from 20 minus 10. Okay, 10 distance, even there it's 10 height. What about from here to here? This is a triangle. This is area 1. This is area 1. This is area 2. This is area 3. What is the base? This triangle, where is this triangle? Let's check. this triangle. Okay, let me use another. Not let me use 50 here. Let's say it's 50 here. Okay, I'm using 50. So the distance of this from here to here, it is 50 minus 20. So it will be 30. So this distance here for this triangle at the end, this one, it is 30. Why? It was got by subtracting 50 minus 20. Okay. So I'm finding the area of this one, and this one. Okay. So area 1. So area 1 will be equal to half base times height. What is half times base is 10, height is 10. From those shapes I drew for you. So that will be 2 there, 1, 2 there, 5. So it will be 50. Okay. Area 1. Area 2, it is L times B. As you can see, area 2 from the diagram, A times B is 10 times 10. 10 times this 10. Okay, which is equal to 10 times 10. This is length times breadth, which 10 times 10, which is coming to 100. Okay, area 3. What is area 3? Area 3 is also a triangle. So half base times height. So half times base is 30 times height is 10, which will come to 2 there, 1, 2 into 10, 5, which is equal to 60. 5, I mean 30 times 5 is 150, not 60, sorry. 150. So is equal to 150. Okay? So meaning distance, which I'm looking for, will be equal to the sum of the areas, right? So distance is equal to area 1 plus area 2 plus area 3. So what is my area 1? My area 1, we got what? Area 1 is 50, area 2 is 100. So 50 plus 100 plus 150, which is coming to 400, I believe. 400 meters. Yes. 400. 50 plus, that's 300, eh? Should be 300, yeah, 300. You have calculator, so you'll be able to do this on your own. So this is 300. 300. Okay. Question C. Question C is calculate the deceleration. Deceleration. Okay. The deceleration calculate the deceleration. The deceleration is where the diagram goes down. Okay, the last diagram. The deceleration is always to decelerate. It means to reduce. So calculate the deceleration. So have you seen the diagram? It was going like this. You remember this diagram the way it was going? It was going like this. Come, you see, this is the way it was going. Now deceleration is this part, this side, the one that is going downwards, this side. This is what you call deceleration. The one that is slanting downwards, this line, it means you are decelerating. So they want us to calculate the deceleration. But for us to calculate the deceleration, we're supposed to know the initial velocity here and the final velocity there. That's how you calculate deceleration. You're supposed to know the initial velocity here and the final velocity there. Okay? You're supposed to know this. Initial velocity, meaning you start from here on top, you end here, because that's where deceleration is. You are going downwards. You are reducing speed. So the formula for deceleration is the same formula for acceleration. So acceleration is equal to final velocity minus initial velocity over time. But when you are decelerating, you look at the diagram. what is my final velocity? My final velocity from the diagram, it means my deceleration is which one? Which part is deceleration? This part is deceleration, this one. Okay? This whole part is decelerating. So it means I'm starting from here, okay? And then I'm ending here. So what is my initial velocity here? My initial velocity here, it is 10. Can you see this is horizontal line? So initial velocity there, it's 10. Okay, final velocity, it is 0. Because I'm coming to rest, I'm stopping. So that's how you do it. So final velocity is 0. So initial velocity, final velocity is 0. Final velocity is 0. On final velocity here, it is 0. Minus initial velocity was 10. Divided by the time it took. How long has it taken for me to move from there to there? Okay, how long have I taken for me to move from here to here? Is this triangle I'm looking at? Have you seen? Is this triangle? It's a triangle I'm looking at. How long has it taken for me to move from here to here? It is 50 minus 20, which is 30. So meaning the time that is the time it took here was 30. Okay, it was 30. So acceleration is equal to negative 10 over 30, which is equal to negative 1 over 3. When you punch this on a calculator, whatever it's going to give you meters per second squared. That's the answer. I'm repeating, retardation or deceleration is the same thing, okay? When they say retardation and deceleration, it's the same thing. So here they can say calculate the deceleration, or they can say calculate the retardation. Retardation is the same word. Okay? And you always concentrate on the line that is slanting downwards. The line that is slanting downwards, that's the one that has got the deceleration. So that's how you do it. Okay? You always concentrate on the line that is going downwards, this one. So it means initial velocity here it was 10, final velocity here it was 0. Okay, I know you have learned something. So this is the answer.